Okay, good morning everybody. This is Mr. Steele. I am of course again not here. I am at an AVID team meeting with the rest of the AVID teachers today working on curriculum. So I am not in class, but at the same time the calendar is pretty aggressive here for Algebra 2 this term, especially in term 2 if it's so short. So I don't want to fall behind. I want to get us working on a skill that really isn't super difficult, but again, like it's just kind of a process you have to get used to. And this process is for dividing polynomials. And what I'll say as you write down your notebook, the title and everything, is that this kind of skill of dividing up polynomials isn't really going to be helpful to us. Like, there's not going to be a nice payoff today as we go through it. We're not going to go like, oh yeah, that's why you divide no, that's not going to happen. But later in this week and next week, when we talk about the factor remainder theorem, we're going to encounter polynomials that we actually don't know how to factor. And we're going to discover pretty quickly that division is actually a technique for breaking them apart into pieces that we can work with and break down. So in fact, division is kind of a skill we'll learn now, practice, get good at, and then start using a little bit later tomorrow or the next day. So anyway, what we're going to do is we're going to start with a simple division problem, one that you could do when you were in 3rd grade, because something we'll discover today is that dividing polynomials is exactly the same as dividing numbers. Like, it's really not that different. There's just, obviously different pieces involved. So when we deal with a problem like this, 1,371 divided by 11, we're going to use the old division algorithm that you learned back in 3rd grade. I'll try to keep the pen colors different, try to make stuff as clear as possible. So of course the first question you're asked if you want to divide 1371 by 11 is how many times does 11 go into 13? And the answer is very clearly 1. 1 times 11 is 11, and then we subtract it off, or in the words we're going to use, draw the line, change the sign. 13 minus 11 is 2. Then next we bring down the 7 and repeat the process once again. So again, just for clarity, I'm going to go to a different color. So next we ask, okay, how many times does our divisor 11 go into 27? Well, it goes in twice. 11 times 2 is 22. We draw the line and change the sign so that we can subtract, and 27 minus 22 is going to be 5. Once again, we bring down the number. So changing pen colors once more. Our final question for ourselves is how many times does 11 go into 51? The answer is that it goes in 4 times. 4 times 11 is 44. Draw the line, change the signs so we can subtract. 51 minus 44 is 7. And now, well, there's no numbers left. So from here, we could just add a dot and a 0 and keep going if we wanted to get a decimal answer, and that might be what we want in a certain context, like say standard quiz question number 7. But if we don't, instead, we can actually just stop here and use the fact that this is our remainder. And in fact, this remainder and the divisor give us a way to add to the quotient and finish it off. That would be by putting in that we have remainder 7 over a divisor of 11. So our final answer here is 124 and 7 over 11, or 7/11ths, or 124 plus 7 over 11. And that is our exact answer. The quotient of 1371 and 11 is 124 and 7/11ths. So in fact, this operation, this division process, is exactly the same as what we're going to do over here. So I'll try to do one with polynomials as our first example before providing a plan and a couple other examples, and then going on to a second way that we'll find will help us divide polynomials really nicely and quickly if they're set up a certain way. So here we go. Okay, I'm back. I actually had just done this entire portion of the video a couple minutes ago, and of course what happened, but the entire computer froze, so it caught right in the middle of like the green line for this first example of polynomial division. So unfortunately I have to start again. One positive though is that I did during that time add up a couple terms that I've been using without even talking about them, so just to kind of clarify those things. When we're dividing, the number that we're dividing into, or that goes under the division line, is called the dividend, just like the number under the radical is called the radicand. The divisor is what we're dividing in with, so in this case our divisor is 11. And then finally the quotient is the result of division. It's the number we get at the end, or our answer for a division problem. So sometimes our instructions when we do any sort of division will say, find the quotient, or they might just say divide the polynomials. So with that said, let's write our first example out and get started doing actual polynomial division. So our first polynomial division problem is going to be 2x squared minus x minus 10 all divided by x plus 3. And so now, as you look at the problem here, this is how it'll be written in a textbook or on a test or a quiz. But in fact, if you've had certain teachers, like you might have already done this before. Like I know for sure that if you had me for Algebra 1 2 years ago, that we did go through polynomial division or long division. So you might have seen this before and it might be a little familiar to you. And then I believe if you also had Mr. Shabbat, I think he did as well. I'm not sure about other teachers. So this might be something you've actually seen before. So it's going to look kind of intimidating because we're really doing all these steps with polynomials, which are a lot more complicated than just 11 and 1371. But in fact, the process will be exactly the same. So I'm going to try to use the exact same colors as I did over here to highlight kind of the steps that we do. Okay, so the first thing I'm going to do is I'm going to put it in the same notation as our division problem over there. In fact, that's not high enough. I'm going to go down a line. So we are going to divide. So our dividend, the dividend is going to be this guy. So my dividend will be 2x squared minus x minus 10. And my divisor is going to be this guy, x plus 3. So we're going to see how many times does x plus 3 go into 2x squared minus x minus 10, or what is the quotient of 2x squared minus x minus 10 and the binomial x plus 3. So the first thing we did was, well, I used a blue pen for this. So I'll do that same thing. So the first question we asked ourselves was, how many times does 11 go into the 13? So how many times does 11 go into that first part of our dividend? So that's what we want to find out. How many times does x, or x plus 3, go into 2x squared? So to do that, like we can kind of just see, okay, what do we have to multiply x by to get 2x squared? So what would that be? Well, in this case it would be 2x, because x times 2x gives you 2x squared. But if you don't see that, you can actually figure out what to put on top there in our quotient by dividing the inside one by that first term on the outside. So 2x squared divided by x is 2x, hence why we have this 2x sitting there. Now to get our next piece, we took that number and we multiplied it times 11. We went 1 times 11 is 11. Well, over here we're going to do the same thing. We need to see what is 2x times x plus 3. So to do that, we're just going to multiply those two pieces. 2x times x is 2x squared, and 2x times positive 3 is positive 6x. Now I don't like having those little things there. I don't usually draw those little rainbows, so I'll get rid of them. But in fact, that might be something that you do. And now, of course, when we got here, we subtracted it away. We figured, okay, well, what's left over when we subtract that out? Like, what are we left with to then divide into? So from here, we'll do the same thing. We're going to draw the line to indicate that we're going to do an operation. Then we're going to change the sign on the entire thing, because we want to subtract this entire thing. We basically want to go, okay, what is 2x squared minus x minus 10 minus this? Well, that's kind of awkward to write out every time, and you'd have parentheses swimming all over the place. So instead, we draw the line and change the sign. So in this case, this is positive 2x squared. We're going to change it to minus. And this is positive 6x. We're going to change it to minus as well. So I make a really big, thick minus sign. Kind of looks like a birthday cake. Let's make it a little smaller. So we change it to minus so that we're again subtracting the entire piece. Now from there, we do the actual subtraction. So 2x squared minus 2x squared is 0. That first term should always make a 0 because of the way we're doing this. And then negative x minus 6x, or negative x plus negative 6x, is going to be negative 7x. And there we go. We've now found out what's left over when we do that piece. The only thing we had left to do was we bring down the next number. So in this case, we bring down the next term, which is negative 10. And now we repeat the process again. And in order to simplify or make clear that I'm doing it the same way as before, I'm going to change to a green pen just like before. So from here, we now need to ask ourselves, how many times does x go into negative 7x? So if you don't see it right away, that's okay. You can kind of think off to the side. What is negative 7x divided by x? Of course, the answer is it's negative 7. So our next number up here in our quotient is negative 7. Then from here, we multiply it by that binomial divisor once again. So negative 7 times x is negative 7x. Negative 7 times positive 3 is negative 21. Of course, I don't like those little things. I'm just doing it for illustrating here. Okay, so back to our problem. We now have our expression. This is negative 7 times x plus 3. We draw the line and change the signs. So it was negative, we'll make it positive. It was negative 21, we'll make it positive also. Now we combine them. Negative 7x plus 7x is 0. Negative 10 plus 21 is 11. And then, of course, at this point we see that there's nothing to bring down. So, of course, we can't bring anything down. We just need to fill out the remainder. So in order to do that, we're going to use the same kind of notation as before. We're going to use like the mixed number way. So our remainder is right here. That's our remainder. And we're going to take that, put it up here with our quotient, and then put it over our divisor. So it'll be 11 over x plus 3. And so in fact this quotient is our final answer. The only problem though is that this isn't really as clear. Like we don't usually use mixed polynomials like this where we just set it next to it. So in order to give a complete answer that's totally clear, like maximally clear, we then just add a little sign here to say, okay, it's just plus whatever my remainder is over my divisor. So in fact our answer here, or our quotient, is going to be 2x minus 7 plus remainder 11 over x plus 3. So we don't ever use that little r notation, we don't just sit it there, we actually have a way to write it out. And so now this is in fact our answer. If we multiplied 2x minus 7 plus 11 over x plus 3 times this guy, x plus 3, we would in fact get 2x squared minus x minus 10. There we go, we've just done polynomial division. So our next step is going to be kind of writing out a plan for how I did this so that you kind of have that down, and then seeing a couple more examples before we try out kind of a different way of doing it. Okay, so this problem over here, I know it just changed location. It's exactly the same stuff as written before. I've just kind of cleaned it up a little bit. So this is our division work, and what we want to do is we want to come up with a written plan to describe exactly how I did that. Now I can admit right now that of all the plans that I come up with, this one's kind of awkward. Like I've actually said before in classes that this isn't something that I can write down step by step. I kind of just have to show you, and you have to kind of get the words and the sounds and the processes in your head. But I tried to write this down last time. I think it actually is okay. So our plan, kind of what we do. So in order to do this polynomial long division, you can basically start by kind of talking about that big important question. And that question is, how many times does that first term go into the other first term? So we'll write that as our first step. How many times does first term, and of course that's the first term of the divisor, go into the first term of the dividend? So of course we can't do all the division. We can't do all of the division at exactly the same time. Like that doesn't actually work that way. There's just not, unless you're a genius, you can't do that. So in fact we start with that question: how many times does it go in? And of course I showed you two different ways. Like one way was just say, okay, what times x gives you 2x squared? The other one was to actually divide the dividend piece by the divisor piece. After we do that, like in step 2, the next thing we did was we multiplied this times that entire binomial. So we multiply whatever came up in step 1, so I'll write it as just 1, by the divisor. And of course this divisor is a binomial, but we wouldn't necessarily have to have a binomial. We could have had a trinomial or something bigger if we wanted to. So that's our second step. We multiply whatever this is by the entire divisor. Like the whole divisor has to be in there, not just the first term, even though that's all we used here. Okay, third step was to do that subtraction in order to figure out what was left so we could divide again. So that's where we do the draw the line, change the sign step. I didn't like that A. Draw the line, change the sign. And of course the reason we do that again is that we're trying to subtract it out, and so it's just a nice way to keep track of signs and everything, because when you're doing long division in 3rd grade you don't have integers or anything to worry about. So this is a little bit better. So we've gotten through that. From there we do the normal division step. We bring stuff down, all the same, and then of course we add going down. So we add up the terms, like each one. So we combined the x squared terms, then we combine the x's to get another term. And of course also alongside that is also bring down, the normal division step. And then finally, we just kind of repeat the process. So I'll write it this way because I kind of think it's memorable. We just rinse and repeat. So we just do the same thing with a new first term. Like our new first term moves from being right at the top, in the top of the dividend, to right here. And our new first term, how many times does x go into negative 7x? Of course we can do that the exact same way as before. Finally, the only other step then is to, at the end, do, at the end, we do plus the remainder over the divisor. So of course that was how we kind of did this mixed number notation. This is just the same as the original mixed number notation from before. The only thing we added was this little plus so that it was a little more clear what was happening at the end there. So there we go. We figure out how many times the first term goes into the first term to get that first little piece of our quotient. Then we multiply it times the entire divisor, just like we did here. Remember, we even did the little arrows on that time, although you don't really have to, and I'm not going to in the future. After that, we did draw the line, change the sign, in order to make it a subtraction problem and make it easier for us. Then we added going down and brought down the next number, just like, so maybe I should even add here next term, bring down next term, to keep the division going. Then we rinsed and repeated. We did the exact same process as 1 through 4 again with a new first term. So maybe I should put that there too. 1 through 4 with new first term. I'm sorry if my voice isn't really ideal for this, but we did have a powder puff scrimmage this morning. The freshmen might have beaten us pretty badly, in fact, but let's not talk about that. And then, of course, okay, finally, back to polynomial division. At the end, we add the remainder over the divisor. So that's just to, again, make it a clear division problem. And so there's our plan. We're going to follow this plan through and through. And in fact, I'm going to copy this plan over, and I'll do another example of division. Actually, I'll do maybe two, just so you see a couple different pieces that can come in. And we'll talk about problems as they come up. Okay, let's take a look at the second example here. Try to make it a little bit more difficult, as well as move a little faster now that we have a plan sitting right next to us and we've seen an actual example. So let's see, let's go with this one. So we're going to divide 4x cubed plus 4x squared plus 5x minus 8 by a divisor of 2x plus 1. So this will be a little bit harder just because we got that little 2 sitting in front there. And we have more terms. Like before we were dividing a trinomial, now we're dividing by a 4-term polynomial. Okay, so first, in order to start the process going, let's start by drawing out the actual division table. I don't know, I can't think of the name of this. I should just look it up on Wikipedia because I could totally pause this and do that, but I'm not going to. So first, let's write in the dividend. So 4x cubed plus 4x squared. In fact, you know what, that's a really poor plus sign, so let's just fix that now. Again, it actually is very important to get in the habit of writing down the problem correctly and being at least attentive to it. Plus 5x minus 8, we're going to divide by 2x plus 1. Okay, so there is our second division problem. So I'll use red just for contrast, and now we can go ahead and begin it. So the first thing, how many times does 2x go into 4x cubed? Well, 4x cubed divided by 2x, that's the same thing. In order to get 2 to 4, we need a 2, and to get x to x cubed, we need x squared. So 2x squared is the first piece of our quotient. Now we multiply it times the divisor. So 2x squared times 2x is going to be 4x cubed. And 2x squared times 1 is going to be plus 2x squared. Draw the line, change the signs. And again, it's kind of hard to make that into a minus sign, but I just make it kind of covered in ink. So when we do the subtraction now, 4x cubed minus 4x cubed is 0. It's always going to go to 0 when we do polynomial long division. Then 4x squared minus 2x squared is 2x squared. Drop down or bring down the next term, which is plus 5x. Okay, next question. How many times does 2x go into 2x squared? Well, 2 goes into 2 once, so we don't need to worry about that. And x goes into x squared x times. So it'll be 2x squared plus 1x, or just x, same thing. And then again we multiply by the binomial. X times 2x is going to, sorry, I probably should have had that there too when we did the multiplication, or when we figured it out. Okay, so x times 2x is going to be 2x squared, and x times 1 is going to be plus 1x, or plus x. Draw the line, change the signs. And again, same problem. So 2x squared minus 2x squared, 0. 5x minus x is going to be 4x. And then again, we're going to bring down the minus 8, that next term. Okay, we got one little piece left, it looks like. So I'll go there. Okay, so next piece. How many times does 2x go into 4x? And the answer is, I would hope you'd see very quickly, 2, because 2 times 2x is 4x. So now we multiply that last piece times the divisor. So 2 times 2x is 4x. 2 times 1 is going to be positive 2. Draw the line, change the signs. It's going to give me 0 and negative 10. So right at this point, 2x doesn't go into negative 10 anymore. The degree is smaller down here. So that's our remainder. And again, remember, we take that remainder, we go up to the top, we go plus whatever the remainder is, positive or negative, over the divisor. So in fact, our quotient here is going to be 2x squared plus 1x, or plus x, plus 2, all plus a remainder of negative 10 over 2x plus 1. And there is our answer. So we have executed the plan, and now we've divided polynomials together. So with that said, we've kind of hit like the task itself, but at the same time, like there are some little catches that can sometimes happen when you're doing division. So that's going to be our next piece, is we're going to go through an example that kind of shows you some of the little weird things that can happen when you're doing a problem. So here we go. Okay, so now what we're going to do is we're going to take it on kind of a new challenge. We're going to face like the biggest thing that can kind of happen when we're doing division, like the biggest stumbling blocks that can happen. So I'm going to write out a problem, and then we'll kind of talk about what the difference is between this problem and the last problem over on the left side. So here we go. Let's do this one. We're going to divide 2x cubed minus 9x squared plus 60 by x squared, plus 3. And so here we go. So here's our old problem, the one we did in the last one, and then here's our new problem, our new example that we want to work on. Well, what I hope you notice, or what I hope you might notice if I kind of point out some of this stuff, is that over here we actually have a really neat and organized situation. Like in our polynomial, we're going down in our degree, like the terms are going down in the degree one degree every step. So from here we have to the third power, to the second power. It's not written here, but this is to the first power, and then we have a constant. And over here we have the exact same setup. Again, the one's not written there, but we got 1, and then a constant. So actually that's really an ideal situation, because then when we do division, as we saw right up here, we see that everything neatly lines up. Like it's really nice and easy to work with. Down here though, on this side, you'll notice that we have a missing term. So let's get another color so I can really highlight this, because this really is a part that catches people all the time. Right here we have what's called a missing term. It's like we don't have everything that we normally would in our polynomial. As you can see right here, we got 3, 2, and what? There's no x term. So in fact, we're missing an x right in here. Like it's like that term's missing. It's like it wasn't included in there. It's like zeroed out. It's gone. Over here, we actually have the same thing. Like we have a missing term of x also. We've got 2, and then nothing, and then a constant. So in fact, what we have is a problem or a situation that would actually cause problems when we go through and try to stack everything up. We'd end up with like terms out of place, it would seem. And so what we need to do is we need to find a way to account for that missing term. So what we're going to do is we're going to rewrite this polynomial, filling in that missing spot so that everything stays organized when we go through and do the problem. So to do that, I'm going to write out the polynomial or the problem again just so we can sign to see it, and then we'll actually insert in the missing term. So here's what we have. I'm just kind of making room, if you will. Plus 60, so same exact thing. Hopefully you don't disagree. It's just this was navy blue, this is black. Then over here we're dividing by x squared plus 3. So nothing actually that different from before. So now, as we said, we need everything to stay organized. We want it to go just like this one: 3, 2, 1, constant, or 1, constant. We want that order. So over here, that's exactly what we're going to do. We're going to insert in a zeroed term. Like right here, we're going to put plus 0x, because basically 0 times x is still equal to 0. So by adding this guy in there, it doesn't change what this polynomial is. It just makes everything organized. Now we've got 3, 2, 1, and constant. So in fact, that's going to help us out. On the right side, we're going to do exactly the same thing. Of course, my phone's ringing right at this moment, so let me just pull that out of the way. Okay, so over here we're going to add that same missing term. We were missing the x term, so we're going to add 0x in there too. So those now account for it. Now we're going 3, 2, 1, 3, 2, 1, constant, 2, 1, constant. Now we're ready to actually do the division. So I'm going to again change pens. Let's go back to black. And now let's actually do the division and see what happens. So from here, there's my little division line. We got 2x cubed minus 9x squared plus 0x plus 60. And then we're dividing by x squared plus 0x plus 3. Now you might be thinking, well, that's not the only real difference here between this problem and this one. This time we actually have now 3 things in our divisor. We have a degree 2 thing down there. Well, that's true, but in fact it's not going to actually change anything we do. Our plan is still going to be the same thing. We're still going to go how many times does that first term go into that first piece. And I'm going to do it all in black if that's okay. Well, you can't tell me it's not okay, so haha, I win. Okay, so how many times does x squared go into 2x cubed? Well, the answer would be 2x, because 2x times x squared is 2x cubed. So now the first piece, 2x times x squared is 2x cubed. 2x times 0x is going to be 0x squared. And 2x times positive 3 is going to be plus 6x. So what you should notice is, we did line everything up. All the 3's, all the 2's, all the x's. So everything's doing what we want it to. Now everything's still stacked. So next step, same as always. Draw the line, change the signs. Again, sometimes it's kind of awkward, but here we go. We've got 2x cubed minus 2x cubed is 0. Negative 9x squared minus 0x squared is still negative 9x squared. And 0x plus negative 6x is negative 6x. And of course, just like before, we can bring down the next term. And okay, we're here. So now we've got the next piece. I want to figure out how many times does x squared go into negative 9x squared. The answer would be negative 9. I think that's pretty clear to see, since you just have to multiply negative 9 by x squared to get that guy. So now we multiply times that whole thing over here. So negative 9 times x squared is negative 9x squared. Negative 9 times 0x is negative 0x. And negative 9 times positive 3 is negative 27. So once again, all our like terms are together. Squareds, x's, constants. So we can go through, draw the line, change the sign. So from here, 0. Negative 6x plus 0x is negative 6x. 60 plus 27 is 87. And in fact, there's our next line. And of course, I'll get rid of those little rainbows. I just like drawing them. And okay, so now we're here. We ask ourselves, okay, so how many times does x squared go into negative 6x? Well, it doesn't. Like, it doesn't actually go in there. X squared is too big. Like, if we were to multiply by anything, it would have to be like negative 6 over x, and that's awkward. That looks like a remainder. So in fact, I would say that we actually know right now that we're done. Like, the degree is too small. So degree is too small. Like, we can't divide in anymore. It's just like back in our original problem. Let's see if I can get all the way back up here. If you remember, once we got here, 7 was just too small for 11 to go into. Well, it's the same thing here, except now it's in polynomial terms. So in fact, we are stuck at this point. Like, the degree is too small. This is actually going to be our remainder. Like this guy, this beast, that is our remainder. And so in fact, when we go up to write it up there, we will go plus our remainder, so negative 6x plus 87, all over the divisor, which is x squared plus 0x plus 3. But of course, we don't need that 0x now. We're just trying to be nice and neat. So in fact, our final answer is 2x minus 9 plus our remainder all over, or over our divisor, which was x squared plus 3. And so there it is. So in fact, in this case, dividing by something with a squared, not a problem. And dividing by something with missing terms, not a problem either. Like, both of those situations work out just fine for us. So there we go. And really, this is the only catch. Like, when you have a missing term, that is really the only catch that you can possibly get when you're going through and dividing with polynomial long division. And even that, as you can see, it's just not that hard. You just have to remember to insert in that 0 term for whatever's missing. Okay, I think we've seen enough here for you to give it a shot and try it yourself. So I'm going to write up 2 try problems in just a second on the next slide, and then we'll let you go ahead and tackle them. Okay, So let's go ahead and do two triads. So I want you to go ahead and, after I finish writing out the problem, kind of giving you some instructions, go ahead and pause the video for a second, for a couple minutes, a minute or two, maybe 3 minutes. It might take a little longer, so we'll see. And kind of work on it, try it yourself, see where you get stuck, and then after that I'll finish the problems for you. Okay, so our first one, we're going to divide using polynomial long division, x squared plus 5x minus 3, and we're going to divide it by x minus 10. And then as our second one, let's go ahead and divide, slightly harder one, 2x cubed minus 3x minus 1 by, let's go, x squared plus 2. Okay, and what I'd like you to do again, if you didn't catch that last part, is I'd like you to go ahead and pause the video and take a moment, go ahead and work through the division, and then in just a second we will come back and I will work through these problems. So once again, please pause the video now. Okay, so I'm assuming at this point that you've paused the video and now you're ready to kind of see the solutions here and check yourself, make sure everything worked out right. So I'm going to go ahead and do both problems. I'll try to move through them a little bit quicker though than normal, just because you've already seen the skill and you've already tried it. So here we go, first one, let me put it in position. So what I'm going to try to do first is just make sure there are no missing terms. So I'm going squared, x constant, we're good. This is just going to work out just fine. It's already as organized as we need it to be. And so we're going to divide x squared minus 5x, or plus 5x minus 3 by x minus 10. First question, how many times does x go into x squared? Well, that would be x. X times x is x squared. X times negative 10 is negative 10x. Draw the line, change the signs. It goes to 0. 5x plus 10x is positive 15x. And we can bring down the negative 3. Once again, x goes into 15x plus 15 times. X times 15 is positive 15x. And negative 10 times 15 is negative 150. Once again, we're going to draw the line, change the sign. It's going to give me a 0 again, and positive 147. And just like before, x is too small to go into, or too big to go into 147, so we have our remainder as 147 divided by x minus 10. The one thing I will say, even as we finish this problem and get our final answer, which is right there, x plus 15 plus 147 over x minus 10. One thing I will say is that people do tend to mess up this last step here, and the reason is you kind of see the end in sight. You can see, okay, this is just going to be a number, so x isn't going to be able to go in. But of course, don't scrounge or don't scrimp on the last step. Like, go through and draw the line, change the signs just like before, and make sure you do that. Like, if you get that far, you might as well get 4 points out of 4 as opposed to 3 out of 4 or something less if you completely screw it up. And so there we go, x plus 15 plus 147 over x minus 10. Next piece, so we're going to use division. Our first piece we can do is we can kind of check for any missing terms in case there are any. And as I bet you see, there's one right there, and there's one, nope, actually, oh, look at that, I fell for it. I wrote the problem and I fell for it. There's one missing here, like we're missing an x squared term, and over here we're missing just an x term. So in fact, when we write out this problem, we want to include those missing terms with a 0 in front, so that it doesn't actually change the problem, it just kind of gives us a placeholder. So 2x cubed, we're going to go up plus 0x squared to insert for that missing term, minus 3x minus 1, and we're going to divide by x squared plus 0x, again, there's our missing term, plus 2. Our missing terms were right there and right there, just like we were looking for. Now we've got everything accounted for, everything will line up neatly. So, over here, how many times does x squared go into 2x cubed? The answer would be 2x. 2x times x squared is 2x cubed. 2x times 0x is plus 0x squared. And 2x times 2 is plus 4x. Draw the line, change the signs. Always awkward when you have to change plus signs into minus signs, but whatever. This goes to 0. Conveniently enough, this goes to 0. That's kind of cool. And then right here we get negative 7x, and we can bring down the negative 1. And so now at this point we ask ourselves, okay, how many times does x squared go into negative 7x? The answer is, it doesn't. Like, we can't put in x squared into negative 7x. That wouldn't work out. So in fact, after only one step of division, we are at our remainder already. And so we can actually finish out this problem. Go 2x plus our remainder. Doesn't matter that there's a negative sign, you can factor out, don't even worry about it, just leave it as is. All over our divisor, which was x squared plus 0x plus 2. But again, for here we can shorten it back out. We don't need the extra terms in our answer. So 2x plus negative 7x minus 1 all over x squared plus 2. Hopefully then both of these problems you got, particularly this one, although again I will admit that the remainder does tend to get messed up the most because you can kind of see the end in sight. Over here hopefully you recognize that there were missing terms in there and you didn't get too fooled by not getting any x squared term here when you divided. So it just made the problem short. And so there we go. We've now seen polynomial long division in all its glory. Okay. What I would like to do now is, now that we've seen polynomial long division, we kind of get the idea there, I'd hope. What we're going to do is we're going to actually show you that there's another way to do polynomial long division that's a little bit cleaner, because as you notice here, from taking our original example from earlier in the lesson, like the first one we really worked through, or the first real long one we did, this can get kind of messy. I mean, it's colorful, I mean that's cool, all those different colors, but all those circles and changing sign, like there's lots of places to make little mistakes. Whereas there is a process that in certain cases we can use that will go a little bit faster and cleaner. So that second process is called synthetic division. And the reason it's called synthetic, it kind of comes from what the word synthetic means. Synthetic just means like fake or unnatural. Like this is where we're going to kind of use only parts of what we see in our divisor and dividend in order to do the division. And specifically we're going to use the coefficients. So first off, what synthetic division is. So it's a division technique, and as I said, it uses only coefficients. So it uses only the numbers that are in front of the x squareds or the x cubes, all those things. Like we're only using those numbers. So we won't actually see the x parts as we go through this. And the second thing is synthetic division. While it's going to be a lot quicker than long division, it only works in certain cases. So the only time it works is when we have a certain kind of divisor. So it's when we're dividing some sort of stuff, any sort of polynomial, by a binomial factor with coefficient 1 on the x and by a number. Like basically this has to be this way. So like we can't divide if it's x squared plus a number, we can't divide if it's 3x minus a number. We have to have either x plus a number or x minus a number as our divisor. So those are the two requirements. And so unfortunately, like I grabbed, it looks like the wrong problem here, so I'm going to go back up and grab the correct problem. I want to grab a certain one, I just have to find out where it is. There we go. So we'll use that one as our first example. So just kidding on that last thing. So here we go, back down. Just like wiping off the board when I screw up and write the wrong thing on there. Just get to do it a little bit nicer, and there's not all that dust, and I don't have to accidentally wipe it on my face. Almost there. Okay, there we go. Okay, so back to the pen. Let's put in our original problem. So the reason I couldn't use that other problem was, of course, as you saw, the divisor wasn't set up. Like that divisor was 2x plus 1. That doesn't fit our model of divisors that work. So here we go. Here's our problem. 2x squared minus x minus 10, all divided by x plus 3. So in fact, what we're going to do over here is I'm going to show you how to set up division for this problem, or synthetic division for this problem. And the reason I'm using one we've already done is to confirm to you that we actually get the exact same answer. So first of all, I'm going to write the problem again over here, so that since you're probably going to be doing that same thing, like you want to see that translation in your notes between setups. And now we are going to actually do this synthetic division. So there are a couple different pieces. Like in synthetic division, we use this little thing I call a synthetic division table, and there's a couple pieces. There's a little spot up here that I call a pivot. That's just my name for it. I don't know if that's technically the name for it. I feel like I caught it somewhere. I don't remember where. And then there's a line down here, because basically our table is going to go right in this area, and then we're going to do the division synthetically, so just using coefficients. So the first thing we're going to do is we're going to write in these coefficients from here, the numbers in front of the terms right on this side. And so one thing I can kind of do is that up top, since we're writing the coefficients from the dividend, like it might be good to actually remember what they are. So right here we're going to write the x squared coefficient, right here we're going to x coefficient, I'll move it over a little bit since I got room. And then right here we're going to write the coefficient of the constant, or the constant itself really. Of course what those are is I see 2, I see negative 1, because negative x is the same thing as negative 1x, and then of course the constant is negative 10. So notice we need to keep the signs with it. That's part of it. We have to have them there so that we can distinguish between either positive or negative in there. Okay, so we've got the first table, we've got the coefficients. Now remember, we're dividing by x plus 3. So what you can kind of see is when we divide an x squared by an x, what happens is in our final answer we end up going down 1 degree. That's part of what makes synthetic division work. So in fact we can kind of anticipate what our final answer is going to look like. We're going to get an x term from dividing x squared by x. Then we're going to get like a constant dividing x by into, or dividing an x term into an x. And then the last one we're going to get is we're going to get a remainder. So in fact down here we are going to fill in the pieces that go with these components of our quotient. Okay, and the last piece. So in order to fill in the pivot, like in order to actually do this, we need to have a number up here. And that number, that pivot, comes from our divisor. So our divisor, in this case, is x plus 3. And to find out what number goes in the pivot, we basically set our divisor equal to 0. And then whatever that number value comes out to be for x, that's what we're going to use as our pivot. So in this case, if I solve it for x, I get that x equals negative 3. So our pivot is going to be negative 3. Okay, so everything's set up. This is now a synthetic division table. Like everything's there. Now the difficulty comes in actually doing the division. Like what do you do? Well, the first thing we do is this first row, we just bring down whatever that number is. We basically add it to 0, and then we go, okay, 2 plus nothing is just going to be 2. It comes all the way down. Okay, and if you look, it says that our first term of our quotient is going to be 2x. Notice that up here, in fact, our first term was 2x. Actually, you know what? I bet I can do this in a different color. That might be kind of cool. So you can kind of see the connection between the two. There we go. Okay, so we bring down the 2. The next thing we do is we multiply 2 by the pivot. So we're going to multiply in order to get this number by whatever our pivot is, which in this case happens to be negative 3. So 2 times negative 3 from right here is negative 6. Okay, so there we go. We've got our next one. We've added going down, now we've multiplied by the pivot to get up here. Now what does that give me? That gives me, let's see, right here I've got negative 1 plus negative 6, because again we're going to add going down. Same way as before, except now we actually have a number here. Negative 1 plus negative 6 is negative 7. So okay, so that says we have 2x minus 7, so that's cool. Now once again we do the same piece. We multiply that value by the pivot, which is negative 3. So negative 7 times negative 3, because the pivot's right there, is going to be positive 21. And now once again, now that we're here, we are going to once more add. So I'll get one more color pen. So when we add going down, negative 10 plus 21 is going to be positive 11, and of course now we're done. So according to this work, it says that my answer, my quotient, is going to be first term 2x, second term negative 7, and then plus a remainder of 11, which of course we notate as 11, or the remainder, divided by our divisor. And our divisor was, of course, x plus 3. So according to this synthetic division, our final answer is 2x minus 7 plus 11 over x plus 3. Was that the same? Yeah, it's the same. 2x, check. Negative 7, check. Plus 11 over x plus 3. Booyah! We got this. So in fact, synthetic division gives us exactly what we wanted. Now, you might say that this is actually kind of uglier than this problem, because it sort of is, and it's less intuitive. Like, you can't actually see the things as nicely. But in fact, when you see the next couple examples, each of which will only take me like a very small amount of time, you'll see that this actually does go really quickly, and everything's really neat and organized on it. So, in fact, let's do that. Let's actually just look at a couple more examples of synthetic division, so you can kind of get it in your eyes and see it, and kind of work through a couple of them. Okay, So let's go ahead and do a couple more examples here. One thing I'll say as I kind of read through my notes and try to find the next example to work with is that this is actually something that I didn't actually learn right away in high school. Like I don't know if I just missed it or what, but like at first, like I always did this really long polynomial division whenever one came up. In fact, when I was in Mathletes, I actually did one that was like an 11-term polynomial, whereas if I'd just known synthetic division, it would have taken me like 2 seconds. Naturally, I got that problem right, but I screwed up the second one. So in fact, synthetic division can actually be very useful. And we will need it later in the week. Like we will absolutely be using synthetic division to save time and space as we're doing some of these more involved problems for the factor remainder theorem. So putting that aside for a second, let's do some examples so you can kind of get synthetic division in your head. So first thing, let's do this one. 2x cubed plus 11x squared plus 18x plus 9. And we're going to divide by x plus 2. So, first thing we'll do is let's set up the actual synthetic division table. Before we do that, we should probably make sure this works. And of course, the way we'll know if it works is by checking the divisor. This is in fact 1x to the first, or just x, plus a number, so we cool. So let's actually set up the table. So I'll get room for the pivot. I'll set up a line for the actual, to separate out my quotient. And then I'll remember what we're doing. So I've got to put up here my dividend, so x cubed, x squared, x, and a constant. And down here, when I divide by x, it's going to drop it a degree to x squared, x, constant, remainder. And it's a really bad R. Someone will make fun of me. There. It's not really better, but whatever. Okay, so now we need to actually go through and fill this in. So the coefficients, it's 2x cubed plus 11x plus 18x, plus 11x squared plus 18x plus 9. And then for my pivot, x plus 2 equal to 0. That is, of course, going to give me negative 2 as x. So my pivot is going to be negative 2. So, okay, we can get started. So first thing, we're going to add 2 to nothing. We're going to get 2x squared. 2 times negative 2 is negative 4. 11 plus negative 4 is 7. 7 times negative 2 is negative 14. 18 plus negative 14 is positive 4. 4 times negative 2 is negative 8, and 9 plus negative 8 is positive 1. And so there we've done the synthetic division. Now, even as I'm going through this, I'm going through it really quickly. So let me just make sure again that this worked. So I brought down the 2, then I multiplied 2 times negative 2 to get negative 4. That's cool. Next, 11 plus negative 4 is 7. Then I multiplied 7 times negative 2 to get negative 14. That's cool also. 18 plus negative 14 is positive 4. I then multiplied 4 times negative 2, which is negative 8, also good. And 9 plus negative 8 is 1. So in fact, it looks like I did in fact do what I was supposed to. So that means my answer here is 2x squared plus 7x plus 4 plus my remainder of 1 over the original divisor, which is x plus 2. And look at that. A problem that would have taken, what, like 3 lines of division, like multiple colors a couple minutes ago, all this talking, we get our answer in under 2 minutes. Like, if it was even that, like, I actually took more time because I was talking and I checked my work. And so there we go. There is our answer. So let's do another one. I know it's moving kind of quickly right now, but again, like, synthetic division is meant to be quick. That's the whole point of making it synthetic. Like, we're cheating a little bit, saving ourselves some space, and using this little table so that we can move quicker through division, or at least certain division problems, because again, they all won't work. So, second example here. Draw a line down the middle. Actually getting better at drawing lines in this little tablet thingy. Okay, so let's divide. Let me find another one on here. Let's do this one. X cubed minus 5x plus 7, all divided by x plus 4. Okay, so we get ready to go. And we go, okay, let's make our table. Let's say we need a pivot. Boink. We need some terms. So we need x cubed, x squared, x, and a constant. And we need, down here, dividing by an x, we'll need x squared, x, constant, and remainder. So okay, we start filling them in. We go, okay, x cubed, it's 1. Next one is negative 5. Next one is 7. The next one, whoa. What just happened there? Like, wait, what's going on? Like, what? Well, let's look at this original problem again. Like, what happened? We have x cubed. Okay, that's cool. We have x cubed. Then we have x squared. Oh, notice there's something missing. We actually have a missing term, just like before. We need to account for that missing term in synthetic division, just like before. In fact, in synthetic division, it's even worse because we're not really seeing what's happening with the x's. If we miss a term, not only do we screw up just putting in the table in the first place, but we actually mess up, like we can't even fill out that first row. So in fact, we need to go back and go through this and fill in that missing term. So I'm going to add a different color for that purpose, make it really clear what I'm doing. So let's go with red again. I think red's really clear. So, oh, it's making me erase that. That's really silly. I don't want to erase that. So, missing term. So looking at our problem, obviously we're going to have to change some stuff, but our missing term is actually right there. We're missing an x squared. So we're going to insert in a 0x squared. Or for synthetic division, we're just going to insert in a 0. So first I'll get rid of all this mess that I was doing to help you recognize what was going on. And now I'll go write it in. So our first piece is the same. We have 1x cubed. Next piece though, this is where we needed our missing term. Our dividend did not have an x squared, so we put in a big old 0 right there. So again, that's our only change. Like, it's not really difficult, it's not making the problem hard, it's just something that we could easily forget and then mess everything up. Okay, so next, for the x's, we already had that, it was -5. And then for the constant, it was still +7. So no other issues there, but we had to put in that 0 for the x squared. Okay, over here, we can probably very quickly see that our pivot is going to be what? Like, look at it. What makes it equal to 0? Well, obviously that's going to be -4. So we'll put in a -4 over on this side. And now we're ready to go. So 1 plus nothing is 1. 1 times -4 is -4. 0 plus -4 is -4. -4 times -4 is +16. Okay, next, -5 plus 16 is +11. 11 times -4 is -44. And then 7 plus -44 is -37. And so it looks like we're at our answer. Once again, I can jump to the answer, and you know, I'm awesome that way. I would do that. But again, just to illustrate and make sure we did everything right, let's just go through it one more time because we're trying to learn this as we go here. 1 plus nothing is 1. 1 times -4, or sorry, 1 times -4 is -4. 0 plus -4 is -4. -4 times -4 is 16. -5 plus 16 is +11. Okay, feeling good so far. 11 times -4 is -44. And 7 plus -44 is -37. So I feel pretty good about this. Let's just write our final answer. It's going to be 1x squared, or just x squared, minus 4x plus 11, all plus -37 over x plus 4, which was our original divisor. And so there we go. We've got our final answer here. And again, we've saved ourselves tons and tons of work, although we did have to realize that we needed to do that same kind of thing that we did for division. Like, we did have to go and fill in a missing term just like we did before. So there we go. There is some synthetic division. So let's go on. We'll do a couple try-its, and then I'll leave you the rest of the period to work on your homework. Okay, so as I said, you've seen a bunch of examples of synthetic division. You've kind of seen how it can transform a problem into something that moves really quickly. And so now you're just going to have to kind of jump into it. So we'll give you a chance to try it. And we'll do 2 different try-its here. And I'll ask you to do the same thing. Pause the video after I've done after I've written out the problems, work them yourselves for a couple minutes. I don't know how long it would take. It depends on how comfortable you feel with it. And then come back together and let me go through them so that you can check yourself and make sure you did them right. And again, I'm sorry, I was going to put a commercial in here or something, but I'm a little afraid of putting in an actual commercial from something other than just like a screaming zombie face, only because I'm afraid that the copyright infringement might keep me from posting like huge videos on YouTube. So I'm just not going to do that. Sorry. You can pretend that someone's dancing around or something. Okay, so here we go. So we want to do synthetic division here and practice it and try it a couple times. So let's do a couple examples. Go 1 and 2. We've got to make them sufficiently involved to make this interesting. So how about we go with this one? 2x to the 4th minus 6x cubed plus x squared minus 3x minus 7, all divided by x minus 3. And let's get one over here, make it a little bit harder. Let's do, okay, cool with that. 4x to the 4th plus 5x cubed plus 2x squared minus 1, all divided by x plus 1. Okay, so once again, just like before, if you can please pause. And hold off on the video for just a minute or two, or for a couple minutes, so that everyone has a chance to work, and then we'll come back and I'll do these problems for you. Okay, pause now, or freeze. Okay, I'm going to assume everyone's back, so I need to go ahead and do these. I will do them in Franklin Purple once again. So first problem, and again, for synthetic, I'm going to still be really careful as I go through it. Obviously, as you get more and more comfortable with it, you might shorten off some of the steps. You might skip out writing some of that stuff at the top. I wouldn't recommend it, but you might. I sometimes do. It's okay. Here we go. We're going to do our first one. We'll do our pivot table. I think that's actually a technical name for it, but if not, whatever. I do what I want. And here we go. So we need an x to the 4th, x cubed, x squared. What you might notice is as I'm doing these, I'm not even looking up at the original problem, because that's where you could kind of screw up. You might go, oh, there's no x term or something, and then you could just like skip writing it. No, I'm just going, okay, first term is x to the 4th, then I go through and write 1 degree down each time. And of course, then when we divide, we'll go down a degree, so x cubed, x squared, x, constant, remainder. And now we need to fill it in for the specifics from this problem. So let's go ahead and let's use a green, emerald green. Okay, so what do we got? Well, our coefficients here, we've got 2x to the 4th minus 6x cubed plus, okay, so plus x squared is nothing there, but it's really a 1. It would be, if there was a 0, it wouldn't even be there. Minus 3 for the x and a minus 7 for the constant. And then our pivot is going to come from here. So what makes x minus 3 equal to 0? I hope that you can see that it's 3 right now, but if not, you can kind of do the algebra. I kind of do it in my head, and I see that it's going to be 3. So now it's everything coming from the problem itself. So the last thing we need to do is we need to do the actual work here. So let's go through it. Okay, so first part, bring down the 2. So 2 times 3 is positive 6. Negative 6 plus 6 is 0. 0 times 3 is 0. 1 plus 0 is 1. 1 times 3 is 3. Negative 3 plus 3 is 0. So it's kind of weird we're getting a bunch of zeros down here. Not that there's anything wrong with that. Like, there's no problem there. 0 times 3 is 0. Negative 7 plus 0 is negative 7. So I'm not going to do the checking step. I know that I feel pretty comfortable in what I'm doing. But I am going to be careful when I write out my final answer. So I do see 2x cubed. Then 0x squared. Well, I could write plus 0x squared, but that's kind of silly. Like, why would you waste ink like that? Or, since it's math class, why would you waste pencil lead that way? So, in fact, don't have to write anything. It's just a big 0 there. Plus 1x, so plus 1x or plus x. No constant, so no number sitting alone by itself. But then we do have a remainder, so plus our remainder over our divisor, which was x minus 3. And there we go. So 2x cubed plus x plus negative 7 over x minus 3. Okay, next problem. So I'll set this all up. Let's do it the same colors as before because that's kind of cool. So let's see. Oop. I don't like that color. Let's go with this one. Okay, so what do we got? Well, we've got a need for a table. So there's our pivot. Then we've got a line drawn. And now we've got to remember what we got. Once again, we've got it to the 4th power. So start writing across, ignoring what's there. X to the 4th, x to the 3rd, x to the 2nd, x to the 1, and a constant. When we divide, it'll drop a degree, so to the 3rd, 2nd, 1st, constant, remainder. And now, one thing you might be thinking is at this point you might go, oh, it'd be short just to write a 3 and a 2. I would recommend not doing that, like actually writing the x to the 3rd or x to the 2nd, not just because it's important to kind of make that connection with long division and to what our answer is going to look like, but because it'd be really confusing to have like numbers written here and numbers written there and trying to remember which one's which. Like, the whole point of synthetic division is organization and cleanliness. So in fact, I wouldn't do that. Don't do that. Okay, next thing is to fill in the stuff into the problem, like to fill in the table. Use green again. So first, I'll do the pivot this time first. So our pivot is going to be the opposite there, so -1. And again, you can't skip on that step. If you screw up that step, the entire problem is going to the toilet. So don't do that. And then for our coefficients, so 4x to the 4th plus 5x to the 3rd plus 2x squared plus 1. There's something missing. We are missing the x term. And so of course we don't have to panic anymore. We've seen this multiple times. There's no problem here. We can just go, okay, we're going to make this a plus 0x. Throw a little 0 in there as our placeholder. No problem, nothing to see here. And then we can fill out the last coefficients with a -1 for that constant of -1. And so there we go. We've got the table set up. Back to work. So bring down the 4. Go quickly. 4 times -1 is -4. 5 plus -4 is 1. 1 times -1 is -1. 2 plus -1 is +1. 1 times -1 is -1. 0 plus -1 is -1. -1 times -1 is +1. And oh, that's kind of cool. Oh, weird. I don't know if we've even seen one of these yet. At the end of the problem, we get 0 remainder. That's cool. It means it divides in evenly. Kind of nice. So our answer, and again, we'll deal with that more later this week, what that means. So for now, 4x to the 3rd plus 1x squared plus 1x minus 1 plus 0 over it. Well, if it's 0 over something, it doesn't really matter. There's no remainder. So in fact, our final answer, a key. And there we go. So we've now seen everything that we might need for division. If we look back at the entire lesson, we started by talking about the original division algorithm we learned in 3rd grade and how that kind of helped motivate what we're going to do in our actual division here. Next, we moved on to creating a plan to kind of go with it and then doing some more problems. Third, we started to extend it to some harder problems. Specifically, we talked about some harder divisors that we might need to work through, not that they posed any issues. Next, we talked about the one stumbling block on division, long division, and as we see later, synthetic division, when a term is missing. And so we figured out that we could just add 0 times whatever that missing term is, or missing like x is, so that we would keep everything organized and be able to still use the division algorithm. Then we tried a few problems and practiced a little bit doing that stuff. From there, we learned about a newer, faster method of using division that only works sometimes, some of the time, not all the time, called synthetic division, that uses this thing called a synthetic division table. We get a pivot from the divisor, and then it just uses coefficients and little multiply, adding kind of pattern to find the answer. And we saw here that these were exactly the same, son iguales. And then finally we did a couple more examples, slowly moving it up. One of these was just straightforward. The other one we did have to add in a missing term, so that's the same as before. No issue in finding it though. It just kept everything organized for us. And then finally we tried a couple problems, and we were able to do them both the same way. In this one we saw that there were some things that zeroed out in the division process. Who cares? And over here we just saw that I could go really, really fast. So after doing this, hopefully everything feels pretty comfortable. I'm not going to give you more tryouts or work through any more problems or even throw up a funny commercial or anything. I think you've got everything you need to be able to divide capably and start in on the homework. So go ahead and do that. I hope you have a great Wednesday. And barring unforeseen asteroid, meteorites, or Godzilla attacks, I will see you tomorrow. So just like before, this is Mr. Steele signing off. Have a good day.